Well, good afternoon and welcome to Water Wednesday. My name is Kathy Schultz and I am the Water Education Specialist with the California Department of Water Resources. Looking in the participant box, it's really exciting to see some familiar names and some new ones too. So if you are joining us for the first time, a little bit of background. We started Water Wednesdays in the spring of 2020 in response to the school closures and everyone staying at home in response to the COVID-19 pandemic. To date, we've had 36 presentations from DWR scientists, engineers, our technical staff and other folks that work in our department, as well as guest speakers from US EPA, the National Marine Fisheries Service, Central Contra Costa Sanitary District, and the Delta Stewardship Council. We've learned about Delta ecology, addressed water equity issues, talked about different career opportunities in the water industry, and lots more. And if you're curious, all of our past episodes can be found on the DWR YouTube channel. The mission of the California Department of Water Resources is to sustainably manage the water resources of California in cooperation with other agencies to benefit the state's people and protect, restore, and enhance the natural and human environments. Now, in the best of times, water management is a very complicated and challenging task. And this year, as you probably all know, we are in a drought. And with that drought, it has gotten even more difficult. Now, periodic drought is part of life in California. We can look back at our written records or even further back by studying things like tree rings. And we can see that these swings from dry to wet years and back again are a normal part of life in California. However, in recent years, climate change has made these swings larger, faster, and more unpredictable. And that makes water management a lot more challenging. To learn about climate change and extreme water, we are joined today by Vanessa Velasco. She is a senior environmental scientist with DWR's climate change program. And Vanessa is actually joining us today from our Southern Regional Office in Glendale, where she works on programs that help communities adapt to the impacts of climate change, particularly on water. So we're really glad to have her here today. And this is, one of the upsides of the past year and a half is we can bring in people, and we know how to bring in people from all over different parts of the state and all come together and chat about things. So before Vanessa gets started, I just want to give a quick Zoom overview, because one of the benefits of doing this on Zoom is we have an opportunity for Vanessa to chat with you. So we did ask when you joined for your cameras and microphones to be off. That just helps minimize all those background distractions that might cut into her presentation. But we do have our chat box, and we encourage you, if you have any questions that come up while Vanessa's talking, or you came here with a really pressing question, to please just go ahead and drop those in the chat box and send them to me. We also have captions. We have a live captioner with us. So if you like having the captions on while you're listening, or you need the captions on while you're watching the program, you just move over from the chat box. They're both down at the very bottom of your screen, and click on the little box that says CC, and you can turn on or off the captions. So that takes care of the Zoom pieces. And so without any further ado, I am going to hand things over to Vanessa. Hey there.
Hi. Okay, it took me a little minute to unmute. Hi, everybody.
All right.
Okay, hi, everyone. My name is Vanessa Velasco. I work for the California Department of Water Resources as a senior environmental scientist, working as a climate change specialist from the Southern Region Office here in the Los Angeles area. I'm here to talk to you about how climate change can make California's dry and wet years much more extreme and cause flopping between the two extremes more common. So let's first talk about California's climate. This big, beautiful state is known to have a Mediterranean climate, which means we have hot, dry summers and cool, wet winters. Only a few places in the world experience this type of climate, and it's certainly unique. One important characteristic of this climate is the time of year in which we receive rain and snow. So take a look at this pie graph. It breaks down which months in California we receive rain and snow. As you may notice, we receive half of the total precipitation for a whole year in just 3 months, December, January, and February. This makes winter rains really important because that's essentially when we're going to receive all the rain we're going to get all year. And it's a lot of rain in just a few short months, which makes storing the water very important so that we can use it in the later months, especially in the hot months of the summer when we receive practically no rain. Since we're talking about water resources, I want to remind everyone of the general water cycle. Of course, we all know that rain comes down from clouds and that water flows into the rivers, shown here as a runoff, and eventually collects in lakes or oceans. Take a look at the water cycle I have here on the side. You can see the happy raindrops are flowing down through the mountains into the rivers. And if we're up in the mountains, we get snow, which later melts and flows into the rivers, again into the oceans. This might be information we're all familiar with, so I want to focus our attention on two parts of this animation. The first being plants, and a reminder that plants need a rain to survive. The soil needs to stay moist for the plants to grow, and there are no fish shown in this picture, but fish in our lakes and rivers also need this rain, and whenever we experience several years of dry weather, known as drought, plants and wildlife in general are in a state of stress. And so I just mentioned the word drought, which I will talk again later in my presentation. And so the second part I want to focus on is groundwater. You can see the raindrops are here at the bottom. They're seeping into the ground, and they're storing underground in natural storage spaces, and that are essentially protected from evaporation. Groundwater is great at storing water and is really important because for many, many years, Californians have depended on this water and pumped it out of the ground to use. Now that we've talked about the months of the year California receives its rain, let's talk about how much water we get each year. You have the word precipitation there on your screen, and that basically means rain and snow, water coming out of the sky. California is very unique in that precipitation varies or changes from year to year. We still receive precipitation mostly in the winter months, but the amount we receive each year is really different. This graph shows temperature and precipitation in California. So we have the triangle here in the middle shown as the average. And the circles show the yearly temperatures from the 1900s, which is basically a historic data set. You have some really wet years up here, some really dry years, kind of all over the place, which again is very normal for California. It's natural and something this area has always experienced. Now the squares are data from just the last 20 years. And what do you notice? It's still kind of all over the place, but everything's a little bit shifted to the right, which is the hotter portion. It's moved into we're experiencing hotter temperatures, even though precipitation is still variable. And this is something new California is experiencing. And it's something that we've never experienced before. And so the obvious question to ask is, well, why? And before I explain the why, I need to first explain the greenhouse effect. This is a natural process that warms the Earth's surface. It occurs when sunlight hits the Earth. Some of that energy is reflected back into the space away from the Earth. And some of that energy does get trapped within our atmosphere due to gases. And these gases are very important. They make life on Earth more comfortable, and without them, we would feel more like Mars. And carbon dioxide is the most abundant gas in the atmosphere, and it's the gas that we exhale when we take a deep breath, but it's also one of the gases from burning coal or gasoline to power our cars. Humans have been adding more of this gas into the atmosphere for decades, with most of it added within modern times. The consequence of adding more heat-trapping gases into the atmosphere is that we have been unnaturally warming our planet for a long time and are beginning to see the effects of climate change. This is why we are beginning to see higher temperatures in California. And science shows us that the planet will be warming about 2 to 3 degrees based on the carbon dioxide we've already released. And so now we're beginning to see higher temperatures than we did before. And take a look at this graph. This zero line is the average from 1981 to 2010. And then the blue bars, and then the red bars show how much colder or hotter that year was from the average. And so what do you notice? There is some variability throughout the years. We have some red bars here and there scattered throughout the entire timeline. But where do you see more of the red bars and where do you see more of the blue bars? Notice how data in the more recent years are different than the past, especially after the year 2000. We now see the red bars clustered together and occurring in a row. When we look at the data we have on record, we notice something new, where the bulk of hot years is recent and the bulk of cold years is in the past, indicating that temperatures are indeed increasing. And so how will warmer temperatures as a result of climate change affect the way we manage water? Well, mountains will not be able to store as much snow as they do today. And as I mentioned earlier, mountains are important for storing snow after storms and slowly melting later when the rainy season is over. And so let's take a look at this graphic. Down here at the mountain, temperatures are a little warmer, so precipitation will come in the form of rain. And now on the top, at least in the Sierras in California, temperatures are below freezing, so we're going to get the precipitation in the form of snow. And in the middle, you have a mixture of rain and snow. In the future scenario shown here on the right with climate change, only the highest portions of the mountain will be below freezing. And that means a lot more water will come down as rain. So as temperatures continue to increase, less snow will be stored on the mountains. More rain and less snow will have two important impacts. Number one, snow melt after the storm will occur earlier in the season than it did before. And number two, more water will come into the rivers as runoff. So we're going to have a larger amount of waters in our rivers immediately after the storm. These changes the timing of runoff and affects our ability to store all of this water so we can use it in later in the year, like in summer when we basically get no rain. This also puts us at a risk of flooding since a greater volume of water is entering the rivers and communities than before. Our current water system is designed to slowly receive water, which is different than the scenario we're expecting to see with climate change, especially during a wet year, when we're expecting to get a lot more water all at once due to climate change. But like I said, California's precipitation changes from year to year. So what does it mean to have a dry year? Well, during dry years, the state receives only a little bit of rain. And it actually, if it persists for a few years, it's considered a drought. These are real photos taken in the recent present. The bottom picture here is of a reservoir in 1991. You see this space between the water and the trees? That's supposed to be filled with water. The water line is actually supposed to be with the trees. And so less rain means less water to recharge reservoirs that people use to store and deliver water when demand throughout the year is needed. The photo on the top is from 2015 and shows how soil also becomes very dry during drought, such that when water finally reaches the soil, it's absorbed instead of flowing out into the rivers where wildlife can use it or the reservoirs where we can use it. And so since rivers, lakes, and reservoirs are all lacking in water, people turn to groundwater to satisfy their demand, which can cause us to use more groundwater than can be naturally replenished in these dry conditions. And these dry conditions could last a few years, which places additional stress on our entire water system. Plants, animals, and especially fish are stressed out too. Basically, there's not enough water to go around and everything is impacted. People, agriculture, and wildlife. And California is left trying to manage the needs of all three and just hoping to receive some rain. And so if rain is what we need, maybe we're wondering, could an extreme wet year solve the problem of extreme drought? And essentially the answer is no. We simply cannot store all the water that is released in very wet years. And in fact, extreme wet years often leads to the problem of intense flooding. Rain comes down as a downpour in massive volumes that doesn't have time to soak into the groundwater or the soil, but instead it simply just flows out into the sea. Also, there is a reservoir capacity that limits how much water can be banked for future years. And frankly, there's not enough space to capture the volume of water during extreme wet years and store it for dry or drought years. Reservoirs cannot be at capacity too early in the season either because storms might come later on and snowmelt will occur. So we need to leave a little bit of room for that additional water, which means the reservoir must be managed carefully so that flooding doesn't impact the communities located down from the river. There is a major responsibility and a balance to protect communities from flooding while also store as much water as possible to meet our demands. And so jumping between these two extremes makes it difficult for us to balance flood risk and future water demands, especially in California, where again, there's so much precipitation variability from year to year. It's difficult to determine when the state will experience a wet or dry year, and when the state is in a drought, it's difficult to know how long it will last. Climate change will further exacerbate this unpredictability by causing a greater flopping between the two extremes of wet and very dry years. Drought and flooding is expected to be more intense and experienced more frequently with constant jumping between the two extremes. Like the photos you see here, you have flooding in 2017, And then you have this picture, which is very recent, just from July 2021, where Lake Oroville is experiencing record low. Again, this is just 4 years apart. And so as you can imagine, this makes planning very difficult. We are forced to flop between preparing drought contingency plans one year and then dealing with flood the next. Climate change will intensify and make more challenging the delicate balance of ensuring Californians are safe and have their water demands met. It seems the new normal is bigger bursts of rain, which is something our current water storage system wasn't designed for. And I say this is the new normal because this is how our water supply used to be. You know, we used to have drought. Maybe this is a drought and then conditions get better. We sort of, you know, experience more rain, it gets more wetter. And then we kind of spend a little bit more time in this neutral zone right here in the middle. And this neutral zone is where the amount of rain and snow we get is normal. These are times where there's no emergency. We're not in a state of crisis. We're not dealing with floods or drought. The amount of water we're getting is manageable, and it's more of what our current water system is designed for, which is more of these normal conditions and less dealing with extremes. And again, I want to emphasize that these extremes would occur historically, but they were just that, extremes, not the normal condition. And now we're looking at these extremes with the lens of climate change. It's showing us that these neutral normal years will occur much less. We're going to be spending more time dealing with the extremes than the actual normals. So to wrap our minds around what this actually means, we're going to be flopping between two states of emergencies or states of danger. Because let's say we have a dry year. We're receiving very little rain, maybe even a record low. And during this time, the state of emergency for drought. So maybe there's mandates for people to use less water. Farmers are struggling to grow their crops. Maybe they grow different crops that aren't quite as thirsty. Maybe they leave some of their fields vacant and don't actually grow anything at all. And our wildlife is impacted. So maybe fish populations decrease or trees are unable to fight off insects like they were before because they're in a constant state of stress, so they die out. This is one state of emergency. Then let's say the next year we receive tons of rain, making it a very wet year, and communities are flooded. Maybe like the photos I showed earlier, where neighborhoods and homes were completely underwater. In both scenarios, you have lives that can be lost, livelihoods impacted, jobs, and government money is spent on relief programs. Because having almost no water is bad and having a whole lot of water is also bad, it just doesn't make it safe. Unfortunately, though, climate change is showing us that we will be faced with these two states of emergencies much more frequently. The good news is the California Department of Water Resources well understands our state is experiencing new conditions, and that we need to act now in order to ensure our water supply is not impacted. To prepare and plan for climate change, the department created the DWR Climate Change Program. Here you have 10 scientists and engineers who make up this program. Together, we collect data and provide it to people around the state, both government agencies and regular citizens, so that we can all prepare for the impacts of climate change. We do a lot of science-based research to better understand what kind of changes we expect to see and come up with new strategies to make sure water stays reliable and the demands of California are met. Even when we're facing this new challenge we've never experienced before called climate change. Thank you.
Great, thank you, Vanessa. All right, here I am, I'm back. Let me go to the chat because we had a whole bunch of questions come in. And all right, the first one is, do the hotter temperatures that we're seeing with climate change, do these affect the amount of precipitation or just the type, like rain or snow? And I think you covered this. This may have come along before you went into it, but.
Yeah, so temperatures, it definitely covers rain and snow. Obviously, if we don't have temperatures cool enough to sustain snow, it's going to come down as rain. But it also impacts just the entire system, like our jet streams and the entire weather system. So certain areas of California will receive maybe more rain, some of them less. So the warmer temperatures do impact not only the type we're going to get, but how much we're going to get. It's going to vary from location in California.
Okay. Usually around this time of the year, we hear something in the news about El Nino or La Nina. And there seems to be this, oh, it's this type of year, we're going to get, this much precipitation or vice versa. Can you speak a little bit, what are El Nino and La Nina, and is it a foregone conclusion how they're going to impact the precipitation that we get?
Yes, I can speak very minimally on this, but El Nino and La Nina are different types of I don't know, what I call them, like streams of water, basically.
They're ocean water currents, right?
Yes.
Mhm.
And so El Nino will bring a lot of water to California, while La Nina, it's going to be a little drier conditions. And truthfully, that's about all I understand of the two
Okay.
systems. I have heard rumors that La Nina is coming this year. Hopefully, it's not the case, since that's not good news since we're in a drought. But we'll just wait and see.
And it can be a little bit different for different parts of the state, if I recall correctly. Is that right?
Yes, that's true. And that's true for a lot of places in California, just because California, it varies so much in type of geography. You know, we have deserts, mountains, coastlines. So yeah, different areas will be impacted differently.
Okay. And it's not a foregone conclusion. I mean, even if La Nina is a drier year, likely on average over time, we could maybe hopefully still get a couple of good storms.
Yes, that's exactly the case.
All right. What about the rest of the West or the United States? Are they also seeing impacts from climate change, or is this something we're specific to California?
No, unfortunately it's not. The greater Western area. So when I say that, I mean like Colorado, Nevada, Arizona, we're all experiencing a record drought at the moment, which not only impacts California, but also the different states, obviously, and our water supply, because we also, at least in Southern California, get a lot of our water from the Colorado River. And so if the Colorado River is also experiencing drought, it's not really good news for our water supply. Just the general area is experiencing very, very dry conditions that, again, it's believed to be produced by climate change, since something really new to our area.
Okay. Let's see, I'm just checking how much time we've got for a few more. What are some of the things that we can do during those wet years to capture some of that increased rainfall? You mentioned that, with the ground being dry, not everything can soak in, and we can't capture it all in the reservoirs, but is there anything we can do to pick up some of that extra rainfall in those wet years?
Yeah, of course. So in more like an individual basis, there's things like rain barrels, which is basically like a plastic container you can use to capture rain when there's a lot of rain. Kind of capture it, store it like for later on. You can decrease your use of water, basically conserve. You can switch your plants from like really thirsty lawns to more native habitat that are more adapted to this like wet and dry conditions. Mm-hmm. And so those are some of the big things. I would say conservation is definitely number one, because if you just develop these habits to use less water, then you're sort of preparing yourself for any type of condition, wet or dry. You're just like dependent less on water, and you're basically prepared regardless of whatever our water supply system is that year.
Okay. We have a question about, and I don't know if this is something that you can speak to, because it may be beyond the scope of what you do with your work, but there's a question about desal plants, desalination for seawater, and using that as a source of water. Do you feel comfortable speaking to that?
I could speak a bit on that. Yeah. So desalination has been talked about a lot, and it's been used, I know, in like San Diego, and I believe Orange County as well. Desal, you could use, let me dial back. Let me explain what it means first. So you take ocean water, you put it through this process called reverse osmosis to essentially take out all the nutrients, all that salts in the ocean water, purify it clean, and then you have regular drinking water. It is a solution, but it does require a lot amount of energy to purify that water, because you're starting off with some water that already is like nutrient rich. And so you need to take a lot of stuff out, and that requires a lot of energy, which also can increase the price of the water. And if we're, trying to be ethical and make sure everybody has access to water, you need to be mindful about the price tag there as well. But, if we really don't have any other solutions, that is a viable source that we can use.
Okay, great. And I'm not sure who sent this to me, but we got a comment that our lead climatologist says that something It's a reference to El Nino and La Nina, but I'm not quite sure what the message means.
Yeah, well, I'm sure they know more than I do anyway.
But
So
it went out to everybody. So somebody can figure it out. They can let me know. And so following up on the desal, you talked a bit about, what people can do to conserve water. And we had a speaker in April, I believe, who spoke about flood managed aquifer recharge, as another source of kind of storing water and having that as a resource that would be available. And that's something that would use probably less energy, I believe, than desalination. Is that correct?
yeah, so that's also something DWR is doing. I talked a lot in my presentation about groundwater. So one thing that we can do to make sure we're replenishing our groundwater, is to let water kind of sit and then seep down underground. And so what we can do when we have a lot of water, use what we call spreading grounds, which is basically vacant area, and let those waters kind of soak in. There's also places that shoot water into the aquifers themselves, shoot them directly underground, to try to like unnaturally replenish. But we need to kind of conserve that space underground. So those are just like two tactics that DWR does to make sure we're having water for the future by making sure our groundwater is getting replenished.
Mm-hmm. Yeah, and there's I know that there's been investments in things like gray water systems and even tertiary treatment of wastewater, used water to go back into the water supply system, I think.
Yeah, and so that's basically getting the most use out of our water. So right now we're kind of using our water just a one-time sort of system. We get clean water, use them in our toilets or wash our hands, and then they're sent out into treatment plants, and then they're sent out into the ocean or lakes or what have you. But if we kind of use that water again, which what you're saying is reclamation plants, like clean it out, and then you have recycled water that you can use for golf courses. You can use them for irrigation. And so that's another way of kind of reusing it. And you can actually technically do this at home. I mean, I have cats, and when I need to change their water bowl, I just use that water and water my plants with that. And then, even that alone, you're kind of using the same water twice. And again, it helps the whole water conservation.
Everything helps. Yeah.
Yeah.
So I just have one more question for you. When you and I talked before this, you're pretty new to DWR. What's the best thing about being here now and working as part of the climate change team?
Yes, so that's correct. I am new. I started back in May 2021. I truthfully, as cheesy as it sounds, just like love working on climate change. I am an environmentalist to the truest form. My goal in life is literally just to save the planet, to be one of these people that are working to make sure climate change, we're prepared for it and that we have water for future generations. So it just makes me really excited to be working for part of the team, because I feel like I'm making a difference each day. I'm just working towards this big environmental disaster we're faced with and trying to make it a little easier for future generations. So I love it.
Awesome. Thank you. Really, thank you so much, Vanessa, for joining us today. This is something new to you and being new to DWR. It's really, really great to have you here. And I want to say thank you to everybody who joined us on Zoom and on YouTube. If you joined Water Wednesdays in the past, we are changing things up a bit. For the remainder of 2021, we will actually be holding Water Wednesdays just once a month. And these are actually going to be on the first Wednesday of the month. We didn't do the first Wednesday this month because of Labor Day, but we're going to be moving to first Wednesdays, really easy to remember. And so our next one will be on October 6th. The month of October is Flood Preparedness Week. It's actually October 23rd through the 30th. And so for our October Water Wednesday, we're going to be talking more in depth about these extreme weather events that we heard about today, and the floods that can come along with them, as well as how you and your family can prepare in case or when a flood occurs. In the meantime, however, before our next Water Wednesday, if you do want to learn more about DWR, please visit our website, water.ca.gov. We have lots of pages on lots of different programs. And if you work with children, whether you're a teacher or a parent or a grandparent or a scout leader, or have just do anything with kids, Please visit our website for our education materials. These are free, and we are happy to share them to help our next generation of Californians learn about water and what they can do to help protect it and conserve it. And if you're interested in learning more, and I hope you are, about conserving water, saveourwater.com has some really great resources and information for you. Lastly, in addition, if you're interested in learning more about specifics about DWR's climate change program or the impact of climate change on water, we have web pages specific to those topics. And if you really want to dive deep into climate change and how it's impacting California in other domains, things beyond water, you can check out California's 4th climate change assessment online as well. Lastly, to stay abreast of what DWR is doing and what's happening with water on a regular basis, you can follow us on social media. We're on Facebook, we're on Instagram, we are on Twitter, and as I mentioned at the beginning, we have a YouTube channel where you can see previous Water Wednesdays, as well as videos on a lot of other projects that DWR has going on. Thank you again, everybody, for joining us. Thank you so much, Vanessa. This was really fascinating. You're getting lots of kudos in the chat. And I want to wish everybody a good rest of the month and hope to see you here on October